Hello friends, I am Dr. Sudhansh Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. And this session of memories, that is Unit 3, is in the continuation, and this second session is about to cover about the various aspects of the memories which we had learned in our earlier session, wherein we had discussed about the primary memories, secondary memories. We have also covered up the semiconductor memories. We briefly discussed about the magnetic memories and the optical memories. Apart from this, in our previous session we had discussed about that what are the various ways to access the data onto the memories, likewise sequential access mechanism and direct access mechanism. In this session, we are going to understand the memories in a bit more details. That is what is access time, what is seek time, what is latency time. That is the time related to the to access the data. In fact. Now, apart from this, we are going to understand the different type of memories and how to calculate the storage capacity of the memory in this session. Also, we are going to cover about the memory hierarchy. So the objectives of the today's session are to describe various secondary storage devices like your hard disk, your floppy disk, DVD-ROMs, CD-ROMs, and to also describe the importance of the memory hierarchy. Now, in our earlier session we covered that semiconductor memories are the electronic memories, and they are using the mechanism of random access. They are quite faster but expensive at the same time. Apart from this, for the bulk storage, we are using the magnetic memories, wherein the nature of storage medium is magnetic. They are quite able to store ample amount of the data, but they are using the sequential mechanism of accessing the data. Apart from this, we had also learned that the optical memories are using the optical technologies. Apart from this, they are using the direct mechanism to access the data. So there is memory hierarchy depending upon the usage, depending upon the processor speed and the hardware available. We need to identify that what should be the optimum amount of the memory that can work all together with the processor. So we will learn all those things as the session proceeds. So the semiconductor memories are actually having some limitations, because apart from that, because they are fast, but they are limited into the capacity. So as a result of which, we need to have some mechanism, some storage mechanism, wherein we can store bulk amount of the data. So as a result of which, wherein the fast speed memories are required, it is the semiconductor memories are the memories which are used for the purpose. But when we need to store bulk amount of data, then optical and the magnetic memories are actually used for. Now, the magnetic memories are actually using the magnetic technologies, and apart from this, we are using magnetic tapes and magnetic disks. And nowadays, the magnetic mechanism are more or less outdated. We are using clouds, wherein we are storing the data, and but there are advantages that the semiconductor memories are volatile, whereas the magnetic memories are non-volatile, but they are using the sequential and the direct access. The magnetic disks are using the direct access mechanism, and magnetic tapes are using the sequential access mechanism. So we are going to understand that what is how the data is being accessed into the different type of memories. Likewise, over here there is a disk organization which is shown over here. There are concentric circles. Let me show you that these are the concentric circles over here. You can see to this figure, wherein there are concentric circles, and these concentric circles are known as tracks. And apart from these tracks, you can say that each track is divided into the sectors. So magnetic disks are actually the surface devices. These devices are storing the data onto the surfaces, where the surface is divided into the number of tracks, and tracks are divided into the number of sectors. So if we say that there is a disk, then there is a surface at the top, and there is surface at the bottom. So if we are having a memory which is having, say, 2 disks, then automatically 4 surfaces are available. and on each surfaces we are having different tracks. So the surfaces are divided into tracks, and tracks are divided into sectors, and on each sector we are storing the data. So there is a calculation formula wherein if a magnetic memory is being given to us, or a disk is given to us, we are given that these many surfaces are there, these many tracks per surface are there, and a track is divided into these many sectors, and a sector has the capacity to store these many data. Then what is the storage capacity of the memory device? So we are going to learn that how to calculate the storage capacity and the storage density of the memory device as the session proceeds. But these concentric circles are referred as tracks, and to each we need to understand that the tracks can range up to 800, and each track is divided into sectors, which are normally in the section from 10 to 100. So these sectors are either of the fixed length or of the variable length, depending upon the technology which we are using, and these sectors in fact are divided into the equal number of blocks. So this is another figure. This is the, you might be seeing about this spindle, wherein the different memories are being just see over here in this figure, a number of disks are being there one above another. So each disk is having the surface, and this pile of disk is actually related to the hard disk, and hard disk is nothing but an online storage device, and they are permanent. Because the online, why we are saying online, because as the computer starts, they are storing the data directly onto the hard disk. So that means they are directly connected to the computer, and whatever data is being processed is being permanently stored onto the hard disk. So the hard disk stores the operating systems also, and we are not going into the detail that how, when we start the computer, how the controls are being passed on, how the what is the role of BIOS, and what is the role of hard disk, where the operating system resides. Just you need to understand, because this is all covered in your previous units, and in this we are saying that the operating system also resides into your hard disk. And apart from this, compilers, assemblers, linkers, loaders, all these things are being taken care by the hard disk, and it is the operating system which formats the hard disk, which defragments the hard disk, which partitions the hard disk into different segments, and this operating system itself resides into the hard disk. So hard disk is actually a pile of disks which is having two surfaces per disk, and each surface is divided into number of concentric circles, which is as shown into the figure, and the concentric circles are known as tracks. The tracks are further bisected into are divided into sectors, and each sector is storing the data. So there is a formula that suppose there is a hard disk or a disk pack, you can say, which is having n plates, then m, that is the number of surfaces, number of recording surfaces, will be twice of the number of plates. If T is the tracks per surface and P is the sectors per track, and if S bytes are stored per sector, and we know that pi is equal to 3.14, then the storage capacity of the disk will be given by m into T into P into S, that is total number of recording surfaces into tracks per surface into sectors per track into bytes per sector. Apart from this, the recording density can also be calculated, and it will be given by the formula which is shown over here, that is SPD. You can say that this SPD, SP, that is bytes per sector into sectors per track divided by the diameter of the disk. So into pi, that is 3.14. So you can identify that what is the recording density, that is what is the data density of any device. So you can understand well by, and we are going to solve a numerical. Say over here an example is given to you. A 2.5 inch diameter disk pack has 6 plates, 256 sectors per track, 5250 tracks per surface, 512 bytes per sector. Determine disk capacity and recording density. So over here we are given the diameter of the disk, that is 2.5 inch, and which is required to calculate the recording density, because the formula for the recording density is S into P, that is bytes per sector into sectors per track, divided by pi, that is 3.14, into D, that is diameter of the disk. Apart from this, the disk capacity is given by M, that is number of plates, into 2, that is N into 2, where we are given 6 plates. So 6 into 2, 12 plates are there. So 12 recording surfaces are there. So you are given MTPS. So formula is the MTPS, that is number of recording surfaces into tracks per surface into sectors per track into bytes per sector. So if we apply this formula, so we are having 12 recording surfaces, so 12 into 5250 into 256 into 512. This turns out to be 7.69 GB. So you can understand that by noting down the physical parameters, you can identify that what is the physical storage capacity of any hard disk. Now, if we apply the understanding to calculate the recording density, then the formula for the recording density is S into P divided by pi into D, where S is your bytes per sector and P is your sectors per track, divided by pi, that is 3.14, into D, that is diameter. So you will get 512 into 256, because 512 is bytes per sector and 256 is sectors per track, divided by 3.14 into D, diameter given to us is 2.5 inch. So as a result of which the recording density is 16697 bytes per inch. So you can understand that how to calculate the recording density and how to calculate the disk capacity. So let's extend our discussion that we learned that how to calculate the storage capacity of the hard disk and the recording density, but we need to understand that in order to locate any data, we need to have the address of that data. And the address of the data is being given by the 3 parameters, that is to which surface the data is stored, on which track it is stored, and in which sector it is. So that means the disk address is specified in terms of track number, surface number and sector number. And these 3 parameters are very much required to access the information from the disk. So disk address required these parameters and the data is always written from the beginning of the sector. So over here in the figure, it is already shown that there are concentric circles, these are sectors, and these sectors are being divided, these concentric circles are known as tracks. These tracks are divided into sectors, and there is a pile of disks, and each disk is having 2 surfaces. So as a result of which we need to have the understanding of the surface, tracks and the sector to access the data. So to access the data, we need to position the read write head. Many a times we are having the fixed head mechanism, and we need to understand what is the seek time, what is the latency time, and the sum of the seek time and latency time is actually the data access time. So access time is equal to seek time plus latency time, and in the broader sense we can say that seek means time required to seek the data, that is time required to move the read write head on a specific track. So the track is moving from inside to outside and outside to inside, where on which surface on which relevant track the data is stored. So to position the read write head onto that particular track, the time required to position the read write head onto that particular track is your seek time. Now the latency time is time required to bring the needed data under the read write head, because once the data is being positioned under the read write head, then only the read write head can read the data or write the data onto the disk. So that means firstly we need to position the read write head on a particular track, and thereafter we need to position the particular sector under the read write head so that the read write head can either read or write the data onto the disk. The disk is rotating. So that means you can understand that there is a disk, and the disk is rotating like this across the axis, and there is a head, and this head need to be positioned on a particular track. So this positioning of the head onto the particular track is your seek time. And after seeking the particular track, you need to find where the data is. So that means the time required to bring the needed data under the head is your latency time. So total time is seek time plus latency time, and that is nothing but your access time. So there are some important observations about the seek time, and the first important observation is that the seek time varies depending upon the position of the ARM assembly when a read-write head command is received. So when the command is received, where the read-write head is positioned, whether it is lying to the inner side of the axis or is lying onto the outer side of the disk. So that means to bring from one end to another end, the time is consumed. So as a result of which, there is some time which will be maximum when the data is lying inside, that is near to the axis, but the read-write is positioned on the outer part of the disk. Then in order to bring the read-write head to the inner section, it will take some maximum time. So as a result of which, we need to identify that how much time is required, and that to position the head onto the particular track, and this time is your seek time. And after that, we are going to understand that this seek time is only associated with the hard disk where there is a movable head system. When there is a fixed head system, the seek time is 0. Because we are having multiple read and write heads, and we need to activate one particular read and write head for accessing the data onto a particular track. So there is no need to move the head from one place to another place, that is from inside to outside or outside to inside. We are having a series of read-write heads, and one particular head get activated depending upon the track we want to access the data for. So there are different mechanisms. So that means one mechanism is a movable head system and other mechanism is a fixed head system. So you need to first, when you are going to attempt the numericals, you firstly need to understand that whether the question is talking about the movable head system or the fixed head system. So when there is a fixed head system, then the seek time is 0. So generally the questions are related to the movable head systems. So apart from this, we are having the latency time, because once the read-write head is being positioned onto a particular track, then some time is being required because the disk is rotating. So once the data is being passed on, it will take one particular rotation to come once again under the read-write head. So the time required to bring the needed data under the read-write head is your latency time. So this latency time is depending upon that what is the rotational speed of the disk. So what is the RPM value. So latency time depends upon the rotational speed of the disk. Apart from this, it also depends upon the distance of the desired data from the initial position of the head onto the specified track. So once the data is being crossed from the under the read-write head, it takes one particular rotation and then only it can come under the read-write head. So it is the rotational speed is very important factor, because if the disk speed is slow, then the obviously the data supply rate will be slow, as a result of which it will affect to the processing of the data. So we are having the magnetic tapes also. And these magnetic tapes are using the sequential access. So when we are talking about the read-write heads and we are talking about the disk mechanism, disk technology, then at that point of time we are going to we are saying that we are exploring the direct access mechanism. But in the magnetic tapes, the data access mechanism is your sequential access mechanism. And it is very important because the storage capacity of the magnetic tapes is on the higher side. So as a result of which, the magnetic tapes are used to take backups for the servers, workstations and the large computers. Apart from this, the main advantage of the magnetic tapes that they are cheaper. So as we had already said that the semiconductor memories are expensive, but they are faster. But the magnetic tapes are slower because they are using the sequential data access mechanism, but they can store bulk amount of data. So as a result of which, we need to have the balance. So in order to have the balance in between the speed and the performance, apart from this, the economics of the memories, likewise cost per storage of the data is also to be looked into. So that's why we are having the memory hierarchy. So we will be understanding what is memory hierarchy and how it is being explored for the processing of the data. So the storage capacity of the magnetic tapes is actually related to this data recording density into the length, because the tapes are into the longitudinal format. So we are having the length of the tape, and we are having some amount of the data, that is the recording density. So per unit length, some recording data density is there. So that data density is to be multiplied by a particular length, then only we can have the storage capacity. So the data, if we want to determine the storage capacity of any magnetic tape, then we need to multiply the density, the storage density, into the length of the magnetic tape. So it is important to understand that apart from magnetic tapes, we are having nowadays pen drives, we are having external hard disks, and these methods and mechanism or technologies are in fact very portable, handy, but there are some disadvantages. Likewise, because of their small size, they can be misplaced, but they are very frequently used to transfer the data from one system to another system. But nowadays the technology which we are exploring are cloud computing, wherein we are using software as a service, peripheral as a service, interface as a service. Many things are available, and cloud technology is very much used to as a memory part. And so pen drives are also the option. You need to understand so as to have the firm footing in the to the classical ways of storing the data. So pen drives is also now outdated more or less, but we are using it in and day out. Apart from this, we are having CD-ROMs. Nowadays, neither the laptops are using CD-ROMs or DVDs, but they generally came into the storage capacity of 650 to 700 MB. They use the optical technology to store the data, and the thing is they are quite handy. But nowadays the slots for CD-ROMs or DVD-ROMs are not available into the laptops, but we are having this as a mechanism. And the data can be once we are having now rewritable CD-ROMs are available, but many a times they are only that once the data is written, it cannot be removed. But generally we were using CD-ROMs to install the softwares, operating systems, but nowadays online systems are available. But for the sake of information, CD-ROMs are also, and DVDs were also the storage mechanism which were using the optical mechanism to store the data. Apart from this, we are using DVDs, but DVDs are similar to CD-ROMs, but their storage capacity is on the higher side. Likewise, we are having say from 4.7 GB to 8.5 GB, and now more storage capacity DVDs are also available, and they are in and day out, we are seeing that they are used to store the operating systems. We are storing the memories. Gone are the days when the memories the movies were available onto the DVDs. So nowadays the things are available onto the cloud, and we are all watching all those things. But DVDs once were there. So DVDs are also again the large storage devices, and but they are quite fragile also. They are prone to say surface tampers. If the surface get say some scratches or so, then you may not be able to access the data. So we learned that we are having semiconductor memories, we are having magnetic memories, we are having optical memories, and we also learned that the magnetic memories are quite store a voluminous amount of data. They are non-volatile in nature, and they are quite storing the data at the cheaper rates. So, but the semiconductor memories are quite expensive, but they can store a low amount of data, and they are volatile in nature. So as a result of which we need to have a hierarchy of memory, and into the hierarchy of the memory we are having the registers. Registers are the fastest memories which are work in synchronization with the processors. Thereafter we are having cache memories which are slower than the registers, and after cache memories we are having the random access memories, or main memories you can say, wherein we learned that RAM and ROMs were there. Apart from this, we are having magnetic disks and the magnetic tapes. So as the size of the storage decreases, the cost of memory is also increasing. So you can say that the cost of storage of data in registers is on higher side, whereas cost of storage of data onto the magnetic tapes is on quite lower side. But the speed of the memory, the register are quite fast to provide the data, whereas the magnetic tapes are quite on the slow side. So after going through this session, I hope you understood that how to find the storage capacity of the memory, how to find the data density calculation is to be performed into the magnetic tapes, into the hard disks, and I hope you understand what is access time, seek time, latency time, what are the different type of memories, and we also learned in this session that what is the relevance of memory hierarchy. And we will be covering more details in our subsequent sessions. Meanwhile, it is advised to go through the modules which are given into your self-learning material, and you will better understand the concept of the memories. Thank you.